This is the FEIT Electric Smart Wi-Fi Dimmer Switch. It is a great option for upgrading your home into a smart home. You can use it to remotely control a dimmer circuit in your house, either in a single pole or three-way configuration. And you can enable integrations with home automation technologies such as Alexa and Google Home. However, therein lies a major flaw in this switch for me. To use this switch, it needs to connect to the cloud via your home's Wi-Fi. If you're like me, you don't want everything in your house connected to some tech company's server, and thus allowing them to track when you turn on your bathroom light. In this video, we will fix that flaw in this FEIT Electric dimmer switch by upgrading the switch to instead only connect to a Home Assistant server running inside your house.
Hello, and welcome back to my channel. I haven't put a video out in a while, and there are two main reasons for that. First, in my professional life, I got a new job, and so I've been putting a lot of time into getting up to speed and kind of learning everything I need to learn in my new place of employment. The second reason is I've been working on a project that is just not what I've traditionally put videos out on. What the project is to make my house a smart house. Now, I could make videos about that, but there are plenty of YouTubers out there that do talk about that, and I'm not trying to compete with that. Instead, today I want to talk about a specific aspect of this project that I did in order to make my house a smart house. You see, I have what was pretty important to me, a design goal. And that main design goal is I didn't want anything in my house connecting back to some cloud service. I didn't need Google knowing what my various cameras are seeing, or Amazon knowing whether my kitchen lights are on or not. And so I wanted to make my smart house such that it is completely run internally by a server that I host myself on a computer inside of my house. So I did that. I am using an open source package called Home Assistant. Again, plenty of videos on YouTube that can describe how to do that. And I've converted most of the smart switches that I bought to use various open source packages such as Tasmota or ESP Home to make them not communicate to a cloud service and instead communicate with my Home Assistant server. However, there was one challenge in doing all this, and that was to put a smart dimmer switch into various circuits within my house. You see, the way my house was built, the various dimmer switches that I have were built into a three-way circuit as opposed to a one-way circuit. And most of the smart dimmer switches out there are built for one-way circuits. And so I had to find a smart switch that could be put into a three-way circuit. And so I found one. I found this FEIT Electric Smart Wi-Fi Dimmer. The good thing about this switch is that it can actually be put in either a one-way or a three-way circuit. And so it's pretty flexible. And I like the aesthetics. But I had one major problem. Like most of the other smart switches that I bought, it communicates with a cloud service, and that's how you operate it. And so I had to figure out how to convert it. The challenge with that is it doesn't use the same microcontroller that most of the other smart switches use. Specifically, it doesn't use an ESP8266 or an ESP32 microcontroller. It uses something else. And so I couldn't use Tasmota or ESP Home in order to update this switch so that it didn't connect to its cloud service. So I had to find another solution. Fortunately, there is another open source project out there called OpenBK that actually does work on the CPU that is in this smart switch. However, it's not as mature, and the process of flashing it is not as well documented. Now, I did find some information from a message board for OpenBK that allowed me to figure out how to update the FEIT Electric Smart Wi-Fi Dimmer with the OpenBK software. However, you had to kind of construct it. And so there's no real good guide to how to pull it all together and update the switch so that it didn't communicate with the cloud service. That's what I'm intending to do with this video, is to show how to convert this FEIT Electric Smart Wi-Fi Dimmer into a standalone smart switch that can communicate with your Home Assistant server and not communicate with a cloud service outside of your house. So let's get into it.
Okay, here's the switch. We're going to open up the box and see what's inside. But before we get started, I need to give a standard disclaimer here. What you're going to be doing in this project is altering a piece of equipment that operates at mains voltage. If you don't know what you're doing, if you're uncomfortable with doing this at all, don't do it. Get someone else to do it for you. Doing this wrong, somehow making a mistake and connecting the wrong wire to the wrong place can be quite dangerous because mains voltage can kill you or severely damage your house. So word of caution, just make sure you're comfortable with what you're doing. If you're not, have someone else do this for you who is either a professional electrician or has done projects like this before and thus can do it for you. Okay, with that said, I'm going to get started. I'm going to show you how I have transformed this switch into a smart switch that only connects to a home assistant server. So let's get the box open and see what we have inside. Oh yeah, here's the switch. It comes with a faceplate. It's kind of convenient. If you're replacing an existing switch, you probably have a faceplate already, and this fits standard decor faceplates. So, you can either use the faceplate to give you, or the one they have already in your house. Here's the switch itself. It's a fairly standard size for dimmer switches, so it should fit with the switch you're going to replace. So that's fine. Other stuff you get in the box is some stickers to help mark wires when you actually install it. This is actually pretty convenient. Understand which wire is the traveler wire, which one's load, which one's ground, and so on. So useful. It also has this installation guide. And I recommend, before you get started with this project, to open up this installation guide and study the wiring diagrams here. This three-way dimmer switch is not configured like normal three-way switches. If you look closely at this wiring diagram, you'll see that one of the traveler wires is actually used to carry the load in addition to the load wire. So study this closely, understand the wiring configuration that you need to use for this particular switch. So I'm going to put that aside and get started on the switch. I keep these plastic containers around. They're pretty convenient in holding screws. Okay, here's the switch. Let's get started on taking it apart. The first thing to do is to get the faceplate off of the back assembly. It's pretty straightforward to do. There are 4 screws around the edges here. You just have to take those 4 screws off. Once you get those screws off, set them aside. Don't lose them. You'll need it to put it back together. And then the next step is to just gently pull this apart. Now, I encourage you to gently pull it apart because there are some wires on the inside that need to separate cleanly. And I'll show you as soon as I get this open. Okay, there you go. Pull it apart. The thing to notice are these wires right here. These 6 wires that are going to pop up from the unit. Let me zoom in so you get a better look. Okay, these 6 wires that pop up from the unit, they actually, if you look closely at the faceplate unit, they actually go through these holes right here on the side. And so when you're pulling it apart, you need to make sure you pull it straight out so nothing gets bent as they're coming out. Furthermore, notice that there is this piece of plastic here. This is the reset switch. It actually connects to a switch right here. Just notice the orientation in which you're taking it out because you're going to have to put it back in the same way. That orientation is, if you look at it from the side, it looks something like this. And it just goes in that hole and then sits flush at the top of that plastic. Now this bottom unit, you're not going to do any more work on this project. So set it aside. There's nothing that you're going to touch on the inside here. You can look at it if you're curious as to how it's set up inside, but there's no work to be done there. The next thing to do is to take this piece of plastic off the back of the circuit board here and take the circuit board off of the faceplate assembly. To do that, we need to remove these 3 screws. So let's do that. Okay, got the 3 screws off. Next, lift up the plastic shield that is over the circuit board. Set that aside. You're going to have to put it back on later, so don't lose it. And then you can very gently pop that circuit board out of the assembly. Carefully lift it at the same time. There, it's out. You can put the faceplate assembly to the side. You won't be working on this anymore. So let's take a close look at this circuit board to understand what we're going to be doing to it. Okay, if you look at this side of the circuit board, you'll see a few items, notably something called TX2, RX2, TX1, RX1. This is the serial interface to the microcontroller here on the circuit board. This is what we're going to be connecting to in order to communicate with the microcontroller to update the software that it uses in order to run this switch. So we're going to have to connect some wires to that. Furthermore, there is this 3.3 volt and ground. As it sounds like, that is where we connect the power to the unit so that we can actually run the microcontroller to install the new software. If you flip over on the other side, you'll see that all of these pins come through to the other side. This ends up being the better side to connect wires to. If you try to connect wires on this side, you run too much risk of having some solder go onto these other components. So I would recommend connecting the wires on this side. And the ones that you want to connect to are these TX1 and RX1 pins, not the TX2 and RX2, just the TX1 and RX1, which if you pay attention as you flip it over, are these two pins here, right? And then 3.3 volts and ground is right there. There is one more connection we need to make, and that's this NRST pad right here. This pad, when grounded, and so we're going to have to connect it to ground, what it does is signals the microcontroller at boot up that it should be put into programming mode. Therein lies one of the challenges for upgrading this board. We need to put this board into programming mode instantly at boot up. So it needs to have this pad grounded at the moment it boots up for it to be able to be flashed with the new program. So we'll get into how we're going to do that. So for now, we need to solder some wires to this pin, that pin, and connect a wire from NSRT to ground. Okay, we're ready to solder. The thing I want to point out what we're going to do is we're going to be connecting this UART to the serial connections here on the board. Now, there are 4 important connections on a UART device. This is one of these, fairly cheap ones you can get online, either at AliExpress or Amazon or anywhere really, that connects a USB to a serial port. What you are connecting is the transmit and receive to the receive and transmit. So importantly, the transmit on the UART gets connected to the RX1 on the dimmer switch board, and the receive on the UART gets connected to the TX1 on the dimmer switch board. Then we connect the power. One important feature of this UART is it needs to have a 3.3 volt output. You can see this UART has both 3.3 and 5 volts. You get it by moving this jumper from either 3.3 to 5 volts, and I have it in 3.3 mode here. If you don't have a UART that can produce 3.3 volt power, you're going to have to get one, or you find a different way to power this board with 3.3 volts. So the connections will be pretty simple. You see what I'm using here is one of these DuPont cables that have female on one end to connect to the UART and male on the other end. I like using these cables for this purpose is because these end tips, they're fairly stiff, and that makes doing a temporary solder to this board much easier to do. So let's get started. In my color scheme, this brown cable is 3.3 volts. This black is ground. This white cable is receive, and this gray cable is transmit. So this one gets connected, the white cable gets connected to transmit on the board, and the gray cable gets connected to receive on the board. Okay, I got the wires lined up more or less. I find the easiest way to do this is to actually put solder on your soldering tip ahead of time, and then holding the wire just above it, and then letting the solder do its thing. You're going to have to leave it in place to let the solder warm up the board so it takes to the joint. Now remember, this is just a temporary joint. It doesn't have to be pretty. You're going to be taking it off when we're done with this operation. The other good thing about using these DuPont cables is you can hold it in place with your finger, and the plastic acts as enough insulation you don't actually burn your finger while holding this in place. As you can see, I have a little bit of a solder bridge there, so I'm just going to drag some off. Okay, I got the wires connected, remove that solder bridge that I accidentally put there. Now to work on the power connections. Before I do ground, I just want to point out the way I'm doing these wires. I've done a number of these devices already, and I found that this orientation just works best. The wires are out of the way of any other connection pad, with the exception of this one here. You just have to be careful about not bridging this transmit to the adjacent pads. Putting the 3.3 volt like this keeps it out of the way of the other ones. And finally, the ground pin, I like to come in from an angle like this. Careful about moving these around too much, because you might lift the wire off of the pad, pulling the pad away, and that's bad. You don't want to do that. That damage the board. So I'm going to go this direction. Now, when you're doing this, the one thing I want to caution you on is make sure you don't get any solder into these holes here. These are the holes that those 6 wires coming up from the switching unit need to go through in order to connect to the main board. So make sure you don't get any solder in these other holes. It's okay. These other holes are just there for testing and purposes like what we're doing right now. Just be careful with these boards. One thing you could do is put some tape over them just to protect them if you want. That's one way to protect that. Okay, now that I got all these 4 wires connected where they need to go, I need to create a jumper from this NRST to ground. So I find the best way to do that is just take a jumper wire. Don't try to make it at this short. I make it longer just because it gives me some more working room with the wire. I recommend the first place to connect it is to the ground pin. Okay, once that's soldered into place, then I bend the wire around. That's probably a little too long. Let me clip that. Then I solder the wire to the NRST pad. Okay, that works. Now that I have it all soldered together, the next thing to do is just test to make sure I don't have any shorts anywhere. So to do that, we use a multimeter. I put it into sound mode. Now the things to test is to make sure that these transmit and receive lines aren't connected to each other, and to verify that. So they're not connected to each other. That's good. Make sure that ground, which is right here, and power is not connected to each other. You'll notice that this pad right here is the 3.3 volt pad. So another thing to check that I like to check is to make sure that the 3.3 volt line on the UART, which is right here, is connected to the 3.3 volt line pad right there. It is, and that works. And then that one's ground, so you do the same thing with ground. Great. Okay, looks like I don't have any shorts. So this is ready to connect to a computer in order to flash it. So let me get that set up. Be right back. Okay, we're ready to flash the software onto the board here. Now, before we get started, one thing we need to do is, from the UART side, disconnect the 3.3 volt wire. The reason for that is we need to start the flashing process before this unit powers up, because as it powers up, it checks the NRST connection, make sure to see if it's grounded, and if it's grounded, then it enters into flashing mode. And the flashing process needs to be already started at that point. So the easiest way to accomplish that is we start the flashing process on the computer. Then once it starts, then connect the 3.3 volts in order to boot the device and have it start the flashing. The first thing we need to do is actually get the software we're going to install. The software comes from this open source project called OpenBK 7231T_app, or OpenBK, an easier to pronounce one. This software is similar to Tasmota and ESP Home, if you're familiar with those. However, it works specifically with the microcontroller that you find on this particular board. Now, you could build the software yourself. In fact, I submitted to this project a Docker-based build environment that allows a person to build the software for any of the target platforms. The software actually works for a number of different platforms. The one that we need is OpenBK 7231T. And so you could build it yourself, but I would suggest that you don't. It's actually far easier to go to the releases on the GitHub page. And by the way, I'll put the link to this GitHub page down in the description of the video. Go to releases and actually get the latest version and download it from them. Now, the version you need to download is BK7231T platform, but the UART flash version, because that's what we're doing. We're using the UART to flash it. So download the OpenBK 7231T _UA _ version number.bin. And then once you download it, I have a directory set up I'm using to do the work from. And once you download it, I'm going to move it to this directory so it's easy to work with. So downloads, OpenBK, there it is. And I'm going to move it right here. Okay. The next thing we need to do is actually get the software that we're going to be using to flash this computer. Now, there's several versions of the software. The one I use is this OpenBK IoT HID _download _pi. It's a Python-based application, so it will run on any platform that supports Python and has access to a serial port. So the easiest way to get this software is just to clone this repository. So I'm going to clone it. Git clone. Then once you clone it, you need to install some packages, Python packages that is, that the software actually needs. The way I like to do this is I like to install packages into a Python environment rather than installing any kind of software dependencies into my global domain of my computer. So I create a Python environment. So Python 3 module VNV to create a Python environment. I'm just going to call it .vnv. Easy enough. And then once that's created, I need to activate it. Okay, now when I install Python dependencies, it'll go into this virtual environment rather than me installing into the global scope of my computer. And it's just a cleaner approach to doing things. If you look what's inside of this directory, you'll notice there is this requirements.txt. It contains all the Python dependencies. So the way you install it is using pip install -r requirements.txt. And pip will go and install all the requirements. You'll also notice frequently there's a new version of pip. Since I'm not going to use this environment all that often, I'm not too worried about it. Now we're ready to start flashing. So the thing to do is to connect the UART to your computer via the USB cable. And you see the UART powers up, but since we haven't connected 3.3 volts to the UART yet, the board is not powered up yet. So to start the flashing, we're going to run the Python program. It's right here in the directory that we're in, the flashing software directory. It's called UART program. You have to give it the file path to the software you wish to install. For me, it is one directory above, and it's called OpenBK. This is what I just downloaded. You need to give it a serial port, and my serial port is at device cu.usb serial. So that's the serial port. And then you need to tell it we want to write. So that's the command for flashing this software onto the computer. So what we're going to do, when I hit return, the flashing process is going to start. And then fairly quickly, not instantaneously, but very quickly, I need to connect this 3.3 volts line. So what I'm going to do is I'm going to be a little bit ambidextrous here, use my pinky to hit the return button, and then connect the 3.3 volt lines. So flashing is started, connected. It's erasing. It looks like it failed because I accidentally pulled the 3.3 volts off while it was erasing. So we can get started with that again. So I'm going to just run the command again, and Get started. Get started. Let's try that again. So every time I've done this, it didn't happen on the first try. You may have to do it a few times. So looks like it's taken this time, so we let it run. You notice the UART LEDs are flashing. Things are working. One time when I did this, it took about 5 times to get it done. So there we go. You see the write successful at the end of the process. That means this board is now been updated with OpenBK software and it no longer connects to the FEIT electric servers, which is great. But now, what do you do about that? So the thing that you do about that, let's go to a browser window here. The thing you do about that is right now this board is in access point mode. That is, it's a Wi-Fi board, but the thing it needs to know is what your house's Wi-Fi is. It doesn't know that yet. So it is broadcasting an access point. It's acting as a Wi-Fi access point itself. And if you connect to it, you can then set the Wi-Fi connection for your house so that this board then connects to your house's Wi-Fi. So to do that, you go to look at what are the Wi-Fi access points around. You can see around my house, there's a lot of access points, but the one you're looking for is down here near the bottom called OpenBK 7231T _ and then some numbers. Those numbers are actually a unique identifier for this board. I think it's the MAC address. I haven't checked, but it's probably the MAC address of the board. So that is the Wi-Fi that you want to connect to. Okay, so once you're connected, then you need to go to a specific web page, 192.168.4.1. That is a hard-coded IP address that this board has been coded to broadcast at when it's in setup mode. So once you're connected to its Wi-Fi access point, going to this IP address will bring you to the configuration page for this board. And here you can start setting it up. I'm not going to set up everything yet, but the thing I do want to do is set up the Wi-Fi that this board connects to. To do that, you click on the config button and then click on configure Wi-Fi. And you can then set it up. You can click this button here, scan local network, and it will tell you all the Wi-Fi SSIDs that it can see. It's just a list for information purposes. In my case, the Wi-Fi I use for my IoT is called Secret Agent. Enter my password, which I'm not going to show you all. Okay, now that the SSID and password entered, you just click submit. The board will reboot, and when it reboots, it will connect to your house's Wi-Fi. So the thing you need to do now is go to your router and figure out what IP address it actually got. I'm going to do that offline for myself. Okay, I'm back. I found the IP address that my board is at, so let's go to it. Now, if you try to reload this 192.168.4.1, you'll see most likely it's not going to load anything because the board's now connected to your house's Wi-Fi, and this address most likely is not a valid address for within your house's network. So it doesn't work. So for me, this board actually got the address of 192.168.2.60, and so let's go to it now. There we go. Now we're at the board. There's a few things more things you want to configure. You can ignore the configure module and general flags. The startup, we're not going to set anything here yet because we haven't programmed the device for the dimmer switch. So that's the next step that we need to do is program this device for the dimmer switch. To do that, let's go back to the main menu. And what you want to do is launch this web application. For whatever reason, this software was kind of split into two parts. There's the part that you just saw, which is a more traditional HTML, and then this JavaScript app that allows you to do other things. The important thing that we want to do here is we need to create a startup file for the device. And to do that, you click on File System, like I just did, And then we want to create a file on the file system. So click on Create File. The default file name that it will create is autoexec.bat, which is exactly what we want. So click OK. And it will create that file. You'll see it as a button here. Click on that button and you now get an editor. The set of commands you want to enter here are these. Now, I'll put this in the video description, and so you can just copy and paste it. What this does is use the OpenBK command language in order to configure the software to communicate with the various things it needs to communicate in order to control the dimmer switch that this board connects to. The important things to understand is that there's multiple channels of control. Channel 1 is just a switch that turns the light on and off. Channel 2 is the dimmer switch, and this is a kind of the variable resistor that allows the light to get bright or dim. And then channel 4 controls the LED that shines on the button. And you're going to be able to turn that LED off, make it bright, or make it dim. And those are the options that this enables right here. All the other details you can kind of gloss over. In fact, I'm going to. I got this off of the message board that I will link down in the video description in case you want to review how people develop this yourself. Now, once it's entered, you just click Save. Okay, it's been saved. Now, the next thing to do is go back to the HTML part of the device's configuration and go back to the config section. We want to click on this change startup command text. Now, what we're going to do is tell the device when it starts up to load the autoexec.bat file and run it. The command for doing that is exec autoexec.bat. So this exactly. Pretty straightforward. Once you enter that, you click Submit. Now, when the board restarts, it will be configured to operate the Wi-Fi dimmer switch that it's connected to. At this point, you have a working switch. All you need to do is disconnect the wires and put it back together. But there's a few other things that you might want to do to make it work within your environment. Probably an important one is to configure names. So if you click on configure names, you see that it has these default names right here. You may want to change it to something that is more meaningful for you. I'm going to be putting this in my hallway, so I'm just going to call it the hallway dimmer. You can't use spaces, so hence the reason why I use the underscore there. And I'm going to use that for both the short name and the full name. Submit and OK. Another thing you might want to do, and I'm not going to do it on this screen, but you might want to change the way this device gets its IP address in your router. In fact, you may want to set it such that it gets a static IP address from your router so that you always know what IP address it has so that you can connect to it remotely yourself without having to kind of dig and find what IP address it currently has. So that's another configuration that I would recommend you do, but it depends on how your router's set up, so I'm not going to give you instructions for that. You're going to have to consult your router's instructions for giving this device a static IP address. Once you've done all that, it's fully set up. One more detail, if you have a Home Assistant server, I did promise that this was going to communicate with a Home Assistant server. I'm not going to give details about Home Assistant and how to set it up in general, but I am going to show you how to configure this device in Home Assistant. But to do that, you need to click on Configure MQTT. This device connects to Home Assistant through an MQTT bus. If you don't know what that is, go find a YouTube video that explains Home Assistant and MQTT, and it will tell you how to use that. The important thing you need to do is set the host here. My MQTT server is running at a host called video.camprath.home, so it'll connect there. The client topic is something to set. This is what allows Home Assistant to communicate with your device. You have to create a topic in the message bus. You can use the default topic, or you can change it to something that's a little bit more meaningful. I'm going to call it hallway_dimmer. Now, group topic, leave it alone. You don't need to change it. For me, I do not have any access control for my MQTT bus. So I'm going to erase the user and the password and then click submit. So you can return back to config. You can look at a few other things if you want, but none of them are too important right now. And so the most important thing to do at this point, if you want to ensure that your device is properly configured before you unsolder the wires and put it all back together, is you want to reboot it. The easiest way to reboot the device is just simply power cycle the board, and I do that by disconnecting the USB power and then reconnecting it again. Give it a chance to boot up, then I can refresh the web page, and you see that it's changed and now looks like something that might control a dimmer switch. You have an on-off toggle, you have a slider, this controls the dimmer level, and then you have something that can set the LED level. Okay, we're not going to operate this stuff right now. Obviously, it's not connected to the switch, so it's not going to do very much. But this confirms that the board is properly configured and set up. And so the next step here is to remove the wires and put the switch back together and install it in the wall. So let's get to that. Now it's time to remove the wires. Now, before we get started, one thing I want to point out is you got to be careful when pulling these wires off. You need to make sure that the solder is completely melted before you pull it off. Otherwise, you'll pull the pad off of the board, and we don't want that. That's kind of a bad state of being, and you might damage the board as a result. So I find the easy way to do that is to have a tweezers ready to go, and you just use it to push it off the board very gently once the solder's all melted. Melt the solder, and then grab the stuff to push it off. If you didn't get it off in time and it hardens, take your time, don't rush this. And my goal right now is just to get the wires disconnected, not to get all the solder off. There, completely off. Now, the goal here is to get enough solder off such that there's no bridges. You're not trying to get, like if any solder got into the holes here, you're not really worried about that because these holes aren't used for anything on the device. They are there for testing purposes. Remember, you don't want to get any solder into these 6 holes here, so be careful about that. So the way I'm going to get this solder off is I'm going to use this suction pump. Heat up the solder. Okay, there we go. The board has been cleaned up. You'll notice I didn't get all the solder off. There's a couple holes that the solder's filled into. Again, it's okay. You don't have to get it all off, just enough such that there's no risk of shorts occurring because of some stray solder or such. Now it's time to put the switch back together. To do that, what we're going to do first is to put this board back into the faceplate assembly. So the controller board goes down this way. So the connections that we soldered at are facing up respect to that. Now notice that there are 3 screws that gets connected. Make sure you find those 3 screws and put it in with the right orientation. Once you do that, next thing to do is to place the plastic protector over the board. Make sure you get the orientation right such that these 6 holes show through. And finally, the 3 screws that you took out, time to put them back in. Okay, now that the switch assembly is back together, we're going to put the switch back together. Now let's get the orientation right on this. First thing to look for, the switch says where top is. That is the switch assembly shows where the top is. And the faceplate, these 4 LED lights go towards the top. So we'll be putting it back together this way. But before we put the back together, take a moment to inspect what you're going to do. Basically, these 6 wires need to make it through those 6 holes. All the while, this white switch here needs to make it into its location. I find the easiest way to do that is to put the white plastic switch into place first. Remember, it goes in with this orientation, and you just slide it in and then seat it. Then you take these two parts, and I put my thumb on the white switch at the bottom just to hold it in place, and you line things up until you can see those 6 wires going into these 6 holes. It may take some wiggling to get it just right, but don't force it. This is not something to force. And oh, by the way, the thing to notice is where the white switch is going. It's going into that hole right there. Okay, I got it. I got the in the holes, and so I can gently push everything together. There we go. Now that it's been pushed together, you attach the 4 screws once again. Attach the 4 exterior screws that hold the faceplate to the switch assembly. There we go. The switch has been completely updated and reassembled, and it's ready to install. Now, I'm not going to tell you how to install this. I'm not an electrician. I don't feel qualified to give people advice on how to do their home electrical connections. I do recommend that you watch a few other videos from qualified electricians that describe how to set up a switch. I also recommend, as I said earlier, take a moment and study the wiring diagram that they give you in the instructions to make sure that you understand the proper way to wire this switch, especially in a 3-way configuration. So make sure you understand that. And then install it where you want to use this as either a 3-way or a 1-way dimmer switch. So I'm going to go do that off the camera, and then I'll come back and finish the setup. Okay, I'm back. I have my switch installed. It works. It actually powers on the lights in my hallway and powers it off, and I can control the dimmer. However, I have not connected it to a Home Assistant yet. So let's go do that. I'm connected to my server that runs my Home Assistant. What you need to do for this is to edit the configuration.yaml file for Home Assistant. Mine is at mount.data/Home Assistant config, and then I'm going to edit the configuration.yaml. Now you can see I have a bunch of other things going on in my Home Assistant, but most importantly are these MQTT entries. This is what is connecting to the light switch. I will put this configuration down in the video description so you can just copy and paste it. The thing to notice, I have two of these dimmer switches installed. Here's the hallway lights dimmer that we just talked about. The important things to understand from this configuration is that, first of all, the platform that you're configuring this for is MQTT. That's how Home Assistant will interact with the switch, is through the MQTT bus, and so that's why it's in the section for MQTT. These are light switches, so the type of MQTT sensor or device is a light switch, and then you can just use a YAML list in order to configure more than one. I have more than one. If you have one, you still have to use a list. The important things are this name object. That is what Home Assistant is going to call this device in the Home Assistant UI. Unique ID is something that you create that uniquely identifies this switch within Home Assistant. This allows you to, from the UI, to change names and attach other metadata to the device. So give it a unique ID. Now, the part that's actually connects to the switch are these topics that you have to set. The command topic, the set state topic, and so on. You remember when I set in the MQT configuration, I set the topic name. That's what this prefix to the topic string, that's what it represents. This is the actual topic within MQTT by which the Home Assistant and the switch are going to communicate with each other. Then the command topic is just /1/set. This is what actually controls whether the light's on or off. /1/get is the state topic. This allows Home Assistant to know if the light is on or off. The brightness command topic, this is what sets the dimmer level, is in the /2/set topic. And the state, which allows the Home Assistant to know what dimmer level the switch is at, is /2/get. Makes sense, right? You also set the brightness scale so Home Assistant knows that it's a value between 1 and 100, that the payload on and off is 1 and 0. That's how it communicates to turn the switch on or off. QoS, I set to 1. I set retain to true so that if the MQTT server ever restarts, the actual command topic is still there for the Home Assistant server to communicate with. And finally, I put in some information about the device. This is to allow Home Assistant to know that all of these various commands and states are connected together on a one device. I give it the configuration URL of this is the URL to connect to the switch directly. You'll notice in the time that I was off screen, I actually went into my router and gave my switch a domain name, switch-hallway-dimmer.camper@home. And what this configuration URL option is it tells Home Assistant what is the URL that a user can use in order to connect to this device directly. So this gives you this UI right here. It gives you this UI that we previously looked at when we were setting up the device directly. Then I set the manufacturer information, FEIT Electric, that is the smart Wi-Fi dimmer. My name is the hallway light dimmer. This is the name I give it. And then an identifier. This is similar to the unique ID. In fact, I just use the unique ID as the identifier. And that's all you have to do to set this up in Home Assistant. Once you set it up in Home Assistant, you got to go to your Home Assistant UI, go under Developer Tools, and you want to check the configuration to make sure that you typed everything okay. And then you just restart Home Assistant. You wait for it to restart. And then under Settings, if you click on Devices, you can see under MQTT, you will find the devices there. I actually have 4 MQTT devices going on. I have 2 FEIT Electric switches, and then I have an air quality sensor that I made myself. Maybe I'll make a video about that because it was an interesting project, and you might enjoy it too. But for now, I'm focused on the dimmer switch. You can go into the dimmer switch UI, and you will notice there's a bug with Home Assistant that for these MQTT switches, and this is not specific to the FEIT Electric switch, it is actually a bug of Home Assistant itself. When it first starts up, it will give the on-off switch for these dimmer switches or any MQTT switch a lightning bolt. The way to get rid of that is to actually just interact with it to turn it off or turn it on, and it turns it into a slider as you would expect. To set the dimness level within MQTT, you just tap on the name, and then you can slide this around to change the dimness level of the light. And that's it. I've done everything to set up this FEIT Electric switch to be configured such that it does not connect to the FEIT Electric's cloud service and instead only connects to my Home Assistant server. I hope you enjoyed this video. If you found it informative, please do leave a comment down below. I'd love to hear from you, see how this project went for you. If you liked this video, please do like it and share it with your friends. If you like my kind of videos in general, I don't make videos often, but when I do, I like to go in depth and explain all the details of stuff. And if you like that, I would recommend that you subscribe to my channel and get notifications when I publish a new video. So that's it for now. Thanks for watching, and I'll see you next time.